Transportation technology is something everyone takes for granted. In the 1980s, we think nothing of getting on an airplane and traveling hundreds of miles with no more than a coat and a few credit cards. Highway transportation enjoys much the same high technology convenience. Our interstate highway system allows driving across an entire state in a matter of hours. A trip that as recent as 30 years ago may have taken days. Our large metropolitan centers use modern highway technology to move large numbers of people and products in and out of highly populated areas rapidly and safely. Highway transportation has become America's strongest tool for economic development on a national scale. In contrast to our vast national modern highway network are billions of miles of county roads, which are only slightly wider today than when used by horse and wagon 100 years ago. Rural communities faced with continually rising road and highway maintenance costs find it increasingly difficult to upgrade county secondary road systems. Road and highway maintenance in many states is limited to annual repair of potholes, rutting, broken pavement, and resurfacing at best. Roads and highways are often obsolete due to insufficient funds to undertake modernization programs. Replacement of major highway structures and the relocation of secondary roads to meet traffic demands for the 80s requires large capital investments beyond the scope of small urban and rural communities. In the Gallatin Valley of southwestern Montana, small farming and ranching communities depend on the county's secondary road system as a lifeline to the state's network of paved highways. County Road Maintenance Superintendent Sam Gianfrancisco plays a continuous game of keeping the 1,000-mile county road system intact and within the annual maintenance budget. Sam talks about his problems.
The way our budget is set up now is strictly just maintenance on what we have now, and that the budget we get just barely covers what we're doing now, trying to maintain the roads that we have to somewhat of a standard that they are now, let alone to improve them at all.
Road maintenance problems, such as these in Gallatin County, Montana, are similar to those in many other states. Large road and highway reconstruction programs which provide funds for major highway relocation, replacement of bridges, and paving of dirt roads simply do not exist. The Federal Highway Administration, in cooperation with various state highway departments, has created transportation technology transfer centers, like the one at Montana State University in Bozeman, Montana. These centers offer current state-of-the-art highway system technology to rural areas within the state, where allotted maintenance funds are insufficient to do more than throw money at reoccurring maintenance problems. Engineering technology available through the transfer centers to county road and highway districts statewide can help them save hundreds of thousands of dollars annually. Current highway construction technology is then applied directly to these problems by county road and highway maintenance personnel within each county. Today we will look closely at 3 ways in which current technology applied to county road and highway maintenance has saved Gallatin County, Montana, thousands of dollars. Alan Jackson, coordinator of the Rural Technical Assistance Program at Montana State University, assists in finding solutions for some problems faced by the Gallatin County Highway Department. Recently, Alan spoke with Gallatin County resident David Goldenstein about a county road problem which seemed to have no new solution.
Years ago, we got by with it pretty good the way it was, but the increased traffic on it has just really deteriorated the road and kept worked up, and it gets awful soft in the spring. In fact, last spring it was closed for about a month,
Is this a spring here that's on the side of the road, or?
Yeah, this water comes from a spring behind Buzz's house up here about a quarter of a mile.
Did they close this road?
Yeah, Ellen, last spring they had it closed for a good month.
Uh-huh.
And this road between here and down between on this side of the hill was just all real boggy. And you could hardly get through it with a four-wheel drive.
Good morning, County Shop. Good morning, Commissioner. Yes, I know we have a mud problem out on Goldenstein. That's a real bad problem out there for us.
Gallatin County Road Superintendent Sam Jan Francisco was faced with finding a permanent solution. An increase in the number of automobiles on Goldenstein Road created a problem similar to those faced by many county road maintenance departments. Sam learned that a non-woven fiber mat, known in the industry as filter fabric, may offer the solution he was looking for.
This road has been a problem for at least the last 10 years for the county because of the increased traffic over it. The county has spent a tremendous amount of money each year trying to patch the mud holes, putting more material in it with no relatively effect at all. So this is the decision we've made, is to try and make a long-term project out of it.
As traffic loads increase, the finish aggregate or surface gravel is pressed into the poor subsoil. As the finish aggregate sinks deeper, small particles of clay, called subsoil fines, rise to the surface through capillary action. Eventually, when all finish aggregate is pressed into the subsoil, only fines remain on the surface. These fines are unable to support the weight of traffic loads. When this condition exists, rutting occurs and the road becomes impassable to normal traffic. With the use of filter fabric, subsoil fines, which rise to the surface by capillary action in high moisture or high groundwater situations, are contained by the fabric below layers of finish aggregate or surface gravel. The groundwater passes through the fabric where it evaporates. Maintaining separation of subsoil from surface gravel eliminates road surface failure. Additionally, incorporation of filter fabric as part of the structural road base provides continuous tensile support to the road structure beneath surface layers and tends to evenly distribute traffic loads over a larger area. The increased load bearing through use of filter fabric reduces the quantity of finished surface gravel required to achieve a specific road surface load rating. This graph illustrates how the use of filter fabric can reduce the depth of surface gravel required to support a specific wheel load. The upper curve represents the depth of gravel required at various values of load carrying capacity. The lower curve shows the lesser amount of gravel required to achieve the same load rating when filter fabric is utilized.
Well, we're going to go in and excavate the top 2 feet of it and lay a fabric material down, and then bring back in 2 feet of clean material. Then we're going to put some fine or some coarse pit run material, a clean material, and then put a cushion coat of 1-inch material over the top of that.
Once the groundwater level is determined through tests, the impacted road base subsoil is removed. Here on Goldenstein Road, excavation of the roadbed to within 12 inches of the existing groundwater elevation was accomplished. Once excavation had been completed and rough graded, large rolls of non-woven filter fabric were rolled into place and covered with new surface gravel to within 6 inches of the finished grade. After the surface gravel was rough graded, a cushion layer of finished gravel was added to provide a smooth riding surface. Final grading, the road surface is ready for normal traffic. The filter fabric below provided separation of layers and additional strength to the subsoil, delivering years of low-maintenance service. A 50% reduction in the quantity of surface gravel required to maintain the load-carrying capacity of Goldenstein Road was achieved through the application of filter fabric. The annual savings in reduced yearly road maintenance will be significant.
The original design on the project was to go in and dig out 4 to 4.5 feet of the material and put 4 feet of material back in at a cost of roughly $40,000. The fabric material that we're using to do the half-mile of road cost us $3,700. We've been able to cut the fill down to 2 feet, so we figure we're saving roughly $20,000 on this particular project.
Now Goldenstein Road is a dependable connecting route between 2 existing paved secondary highways, reducing driving time and distance for commuters and agricultural traffic. Yearly maintenance has been minimized to minor surface refinishing through the application of current technology. Technical assistance may be easily obtained from state highway departments and rural technical assistant program information centers located in many states. In another part of Gallatin County, near the rural community of Three Forks, Montana, the Old Town Bridge, erected in 1894, had become obsolete for traffic loads of today. As decades passed and traffic loads became heavier, the 4-ton load limit of the original design failed to accommodate the needs of the community. The school bus, which is used on the Old Town route, weighs 8 1/2 tons, over twice the rated load limit.
Every day we had to cross the bridge 2 times, once in the morning and once in the afternoon. We were afraid the bus might fall through. Sometimes we even had to get out in the rain and the snow.
The options for the Old Town Bridge were few. The limited maintenance budget of Gallatin County ruled out replacement of the structure with a larger concrete bridge capable of supporting a bus full of children or a truck filled with grain. Engineering data obtained free from sources such as the Rural Technical Assistance Program provided Gallatin County with a solution to this highway problem. Gallatin County Bridge Foreman Bob Jordan explains.
We had to stop for 1 term before we fixed the bridge and let the kids out and let them walk across the bridge.
I'll be darned. I bet they love you in this area here for getting that fixed. Why don't we take a walk down and show me what the county did to this bridge?
Okay.
Alan Jackson, coordinator of Montana's Rural Technical Assistance Program in Bozeman, here with Gallatin County Bridge Foreman Bob Jordan, keeps abreast of technical information resources. The Technology Information Center at Montana State University acts as a resource clearinghouse for technical assistance in solving road and highway engineering problems.
Well, we decided that the floor beams were the weak point of the bridge, so we had to strengthen them. And to do it, we come in and put these channel irons on top of the floor beams and bolted them down.
Putting these timbers in this modification is a lot better than having to rebuild it. I think the state came up with an estimate of something like $350,000 to replace this bridge.
That's right.
And so for roughly $8,000 or $9,000, the county did the job and saved a lot of money.
It still won't handle the real heavy traffic, but it does handle a lot more traffic than it did before.
What do the farmers and ranchers back of this bridge do now? That do they have another road that they can go on if they have heavier than 10 ton?
If they have a heavier than 10 ton, yes, they can go out about 6 or 7 miles farther and come in on the interstate.
I see. But this will get the school bus across and any local traffic.
Right.
Structural analysis of the Old Town Bridge by state highway engineers brought about an inexpensive solution to this problem. Routine replacement of the wooden deck and stringers exposed the steel floor beams so that structural modifications could be accomplished at very little additional cost. The first step was to strengthen the floor beams, the bridge's structural backbone. The old deck and stringers were taken off and large steel channels were placed on top of the floor beams and bolted down on either side. The placement of the bolts were carefully designed to fit the bridge. The deck and stringers were replaced with pressure-treated timbers. Large steel channels bolted to the floor beam's top flange effectively raised the load limit from 4 to 10 tons. Additional repairs to the bridge struts by a process known as flame straightening eliminated the need to replace struts that had been damaged, either by overload stress or by vehicles striking one or more of the members. Flame straightening is a technique where deformed or stretched steel is shrunk with heat back into its original position, equally supporting its portion of the entire load. This technique involves a process of heating and cooling that few people thoroughly understand. Flame straightening requires specific conditions being met in order to be cost-effective. Montana State Department of Highways engineer Jack Walsh explains.
Some of these members had been struck by loads, and this one in particular.
Yeah,
it has resulted in a condition of this carrying no load at all, this one carrying all a load.
Oh, yeah, you can see this one here doesn't move at all, and the whole load is on that one member, isn't it?
And because this is very mild steel, it stretched when it was struck by whatever it was. And but by a technique known as flame straightening, you can shrink this back to pick up some of the load so that they function together and make a uniform pull on the joint down here also when the bridge gets loaded up.
So you can straighten the kink in that and then also shrink it so it'll take up the load?
That's correct.
How long does that take, Jack?
The time of heating is very short. The time of shrinking actually occurs from the cooling. Now, a day like today, it's just going to be warm. It takes a long time to cool because you have to have a lot of cold steel alongside. And if we had down to 0 degrees, it would shrink quite fast, relatively. Mm-hmm. And so, but it also is a manner in which you do it and the temperature that you use that's very critical. You don't want to damage what you've got left, and you want to improve what you've got there. And so you want to stay under 1200 degrees, which is actually in the annealing range of steel. And you also want to make sure that you have enough cold metal on either side to restrain it in the position it's in. Otherwise, it will want to expand when you heat it rather than just bulge.
Do you need any special equipment like you've got a tip there? Is that a special tip? Or?
It's a welding tip. There's several kinds that can be used. This is the one I use myself. It works very good on these size members that you have on these older trusses and some of even our heavy-duty trusses on the primary and interstate system. What you want to do is put as much heat in the manner that you want to, up to the temperature you want, as quickly as possible, because you don't want to have too much steel heated up. Otherwise, it defeats the effectiveness of the technique. This one here, we can flame straighten, and we will, and shrink it back to so it's parallel to this, and it will have some of the load. We don't know if it will have exactly half, but it will be sharing the load instead of just the one member doing it. On our bridges, I've made several comparisons, and most of them figure out as flame straightening, even including if you have a cracked member where you have to do some welding. We end up with 40% of the cost of replacing that member, even after you have to do some of the flame straightening anyway.
What I'm going to do here is heat this in a triangular shape and just go over it once and walk away from it, because we want the cold steel alongside to do the upsetting of the steel
so that it bulges, and then when it cools, it shrinks. I must have. Wonder why I lost the heat. There we go. Now we let the temperature do all the work for us. Now usually when we have a work on a bridge, we have about 3 or 4 different places, so we just move from place to place so that we don't just sit around and have an easy job. But this temperature has to get down to hand temperature for the coldness of this to allow it to shrink back. And it'll shrink in the pattern of which I did that. What we have here is we did this in a triangular shaped heat because this member is not parallel to this member out here. And we want the greatest shrink to occur on the bottom part so that this member will shrink up like this at the same time that it's going to start pulling together. And so we started out here on the heat, and we just moved back and forth and come out as a triangle as far as the heating effect on that member, and we just walk away from it after that. It probably would take around a dozen times in that one location and a couple times on the ends to accomplish this. Depending on the temperature, then you end up whether, if you do it in cool weather, you can probably get that all done in one day. If not, somebody like Ike is going to have to come by here on his road trips and give it a shot once in a while to gradually get it back in.
Flame straightening is a technique where deformed or stretched steel is shrunk with heat back into its original position, equally supporting its portion of the entire load. This technique involves a process of heating and cooling that few people thoroughly understand. The area being repaired is heated in a V shape so that the steel bulges. A cooling period then allows the steel to shrink back into shape, almost identical to its original position. If there is not enough cold steel on either side of the area being treated, the heating will only lengthen the member instead of shrinking it back into a strong unit that can support its share of the load. Flame straightening requires specific conditions being met in order to be cost-effective. The process is relatively inexpensive and, with the proper training, rather easy to accomplish. Eventually, the Old Town Bridge was completely upgraded at a fraction of replacement cost. After these modifications were completed, the state can raise the load rating of the bridge to 10 tons. Although time has changed the needs the Old Town Bridge must fill, it still provides a vital link between the community of Three Forks and Montana. You have seen 3 examples of highway technology applied to county road and highway maintenance. These are only a few of the many ways small rural and urban road departments can use engineering resources available to them to overcome maintenance problems whose apparent solution may be cost prohibitive. The obvious solution to road maintenance problems may often be impractical or beyond reach from a budgetary viewpoint. With maintenance and repair funds at the county level stretched over hundreds of miles of roads and highways which provide the economic livelihood of rural communities, application of today's highway technology becomes even more valuable. When the solutions to road and highway maintenance problems can be obtained economically, everyone benefits. The examples you have just seen were only an introduction to specific techniques. Their applications to other situations should be carefully analyzed and performed by qualified personnel. The National Highway Institute of the Federal Highway Administration provides a 4-day workshop on the use of filter fabrics that is available throughout the United States. Information about this and other courses may be obtained from your local Federal Highway Division office or from Rural Technical Assistance Information Centers. This program has been made possible by the Rural Technical Assistance Program of Montana State University in cooperation with the Montana Department of Highways and the Federal Highway Administration. If you have questions regarding transportation technology, call 406-994-6103 for more information.